So hi, this is Abhilash and we are going to solve a particular problem which is lead code 1110, delete nodes and return a forest. So in this case, the question is we are given a root of a binary tree and each node in the tree has a distinct value. So there are no repetitions. So the first thing which you can take from this is if we are using a set, then there won't be a problem in this case. So after deleting all the nodes with a value to delete, so we are left with a disjoint union of trees, that is a forest, which is quite right. Because if we try to delete, let's say 2, we'll be left with 4 and 5, and the rest of the left right subtree, 1, 3, 6, and 7. So we have to return the roots of the trees in the remaining forest, and it can be returned in any order. So if we see the test cases, so the first case is 1, 2, 3 up till 7, and we have to delete node number 3 and 5, which contain the values 3 and 5. So if we delete 3, so 6 and 7 will be returned, and the subtrees, if they had subtrees under it, they will be returned. And if we delete 5, then 1, 2, and 4 are left. So that will be returned. Okay, so this can be solved with the help of some DFS approach. So since if a node is deleted, some important points, if a node is deleted, then we should be concerned about its children or subtrees. So push the subtrees or children in the vector, since we have to return a final vector of tree nodes. Okay, so if a node is deleted, we have to take care of its children first before deleting that particular node. So for this, since the values are distinct, we can use a set. Why are we using a set? Because if we want to look up for a particular value in this to delete vector, it will take O of n in the worst case. But set has O of 1, so that will speed up the things. So let's have this set, and we are going to push all the values of that particular vector, which is to delete, inside that particular set. And so inside that particular set. So for this, we'll be inserting I, right? All the elements inside in a particular set. So this guarantees non-duplicate or distinct elements. Now let us create since we'll be looking for the children first rather than the parents, so this will be kind of a post-order traversal. And for that, I have to create a function. So let us call this function DFS. And since we have to output certain a vector of tree node, so let us create a result vector. So we are going to pass this root s and res, that is the result. So let us first create this particular function. So void DFS, and since this is a post order function, we first pass in the arguments in this case. So an important thing here is that we should include the ampersand, because not only are we passing that pointer, but also the memory address, because if a particular root is null, and if we delete that particular root node, then I want this 1, 2, and 4 to be also be returned. And for that, I have to put the memory address of that root node here, and I have to retain it. So let us include the other arguments. In this case, this is s, and the vector of tree nodes, which is the result in our case. So once we have the variables, the first checking is if the root is null, then there is no point going down, so we return it. Since this is post order, so we will check, we will pass the root left and root right correspondingly. Since we want to preserve 6 and 7 and the subtrees behind it before we delete that node, so DFS root left s and res, DFS root right, say right s and res. Now for the final step, check if the root val, current root val, is there in the set. So what will we be doing in that case? So let's say if s.find root val not equals to s dot n. So this means that root should be deleted. So before we delete root, which is we can do simple root equal to null, which will cause that root to be deleted. We have to first push the children in the result because we want to store the children. So let us check if root left, then we'll be doing something, and if root right, we'll be doing something. So in this case, we'll be pushing back the root left value because we want to preserve 6 and 7 in our example, and the subtrees will be preserved by this DFS iteration. So this will give us the first result. And in the second case, if we just return this res, we'll be getting a different value because we'll be getting only 6 and 7. The reason being that we have not processed what will happen to 1. So if the root is not null after all the deletions, then that has also to be included. So in that case, we can put a check. If the root is present, then we can push that root back in the result vector. Now this is very important because since we are doing a post order, we have to check if the final root is null or not, because we'll be missing out on the tree, on the total tree itself. So if we were to do it over here as well, so if we return only this particular res value, we would have gotten only 3. But we have to return or preserve the entire tree. So in this case, if we run now, then hopefully this algorithm should work. Okay, so yes, this should be root in this case. So if we just use this particular algorithm, which is a post-order traversal, then this is accepting in this for this particular test case. Let us try to use some other test case, which is provided here. And since this is a post-order traversal, the children will always be taken care and will be included first before we move into the parent node. So yeah, so this also includes 1, 2, and 4, which seems correct. So if we submit this, so this is okay. So this is one way of solving this particular problem. So there is another way of solving this particular problem if we were trying to use some pre-order traversals. So if we were trying to use a pre-order traversal, then some important points. Since the root is considered first in pre-order traversals, we have to take care of the children first. So this can be designed by using another Boolean counter, right? Whether if the root is null or not null, right? If the root is null, then we can enqueue or push back that particular leaves or subtrees, right? Or children in the vector array or the vector. So this can also be solved with in-order traversal as well. So DFS is the generic approach that we have, that I have tried. And in this case, we have seen that this gives an easy solution. This question is possibly a question asked in many interviews, and quite a popular one, and quite a good question for testing DFS tricks. So hope you can solve with pre-order traversal, which we'll be covering in the next session. So hope to see you guys soon.